Alright, in this video I'll be teaching you how to solve quadratic inequalities as well as simultaneous quadratics and modulus quadratics. So first let's start with quadratic inequalities. We'll use an example for the explanation. I already have an example in mind, which is x square minus 3x minus 4 is more than 0. Now in this inequality, they are asking you what values of x would mean that y is more than 0. So basically what they're saying is, if there's a graph plotted over here, what values of x will mean that y is above the y-axis, above the x-axis. So basically over here, they want to know what values of x will give y as an answer over here. So in order to do that, the first thing that we need to do is solve the equation and find the roots. Now in the last video I taught you the easiest method on how to find the roots, which is the quadratic formula. So let's do that. This is A is 1 basically. If there is no coefficient, it means the coefficient is 1 because it's multiplying with 1. This is B and this is C. The quadratic formula was x equals minus b plus minus under root b square minus 4ac over 2a. So if we input the values over here, it will be minus b, it's minus 3, so it will be positive 3. 3 square minus 4, a is 1, c is minus 4, 1 minus 4. And 2a, 2 into 1 is 2. When we solve this, we'll get 9. Minus 4 into minus 4 plus 16 over 2. This will lead to 3 plus minus under root 25, which is 5 plus minus 5. So we'll get 3 plus 5 over 2 as well as 3 minus 5 over 2. Now these values will be 8 over 2, 4, and minus 2 over 2, minus 1. So this means that the graph looks something like this. Since a is positive, it means the graph has a minimum point. So the graph form will look like this. And the roots are 4 and minus 1. So if we mark 4 and minus 1, the graph should go like this. That's right. Now we have to find out what values of x are above the x-axis. So basically you can see over here that these values are below the x-axis. This is the x-axis, so these values are below the x-axis, and these values, the ones that are in blue, are above the x-axis. Now we have to find a way to write these down, and that's really easy. Above the x-axis we have more than 4 and less than minus 1. The values of x that are less than minus 1 above the x-axis and the ones that are more than 4. So we will write x is more than 4 and x is also less than minus 1. That's as easy as it is. All we had to do was find the roots. Once we found the roots, we sketched the graph, and according to the graph we use the roots to find these inequalities. Because x was positive, the y was positive when x was more than 4, and y was positive when x was less than minus 1. Let's try another example. I've written down the next example, which is 2x square minus x minus 15 is less than equal to 0, which means that in this question they're demanding us to find the values of x for which y is negative or below the x-axis. So we'll follow the same steps for the previous question, which is find the roots. In order to find the roots, I'll be using the quadratic equation. You can also use factorization, whatever suits your needs, but quadratic equation gets it done really quickly in my opinion. A, B, C, which is 2, 1 and minus 15. Let's note down the quadratic formula. B square minus 4AC, 2A minus 1 plus minus under root 1 square minus 4. A is 2, C is minus 15 over 2A, 2 into 2. X will be minus 1 plus minus under root minus 15 into minus 4, 60 into 2, 60 into 2, 120, 120 plus 1, 121. 4, 2 into 2, 4. Then we'll get minus 1 plus minus 11 over 4. This will turn out to be 10 over 4. 10 over 4 is 2.5, and we'll get minus 12 over 4, which is minus 3. Now that we found the roots, we can easily sketch the graph. A is positive, which means that the graph will have a minimum point. That's how it'll look, and the roots are minus 3 and 2.5. Now they've asked us to find the values of x for which y is negative, and as you can see, the only parts in which y is negative are the area between 3 and minus 3 and 2.5. So this area is beneath the x-axis. In order to represent this as one expression, we can write minus 3 is less than equal to x is less than equal to 2.5. And there you have it. That is the answer for the question, because this part is below the x-axis, and that's what they asked for in the question. Now all you need to do to solve quadratic inequality questions is follow these steps. Number 1, find the roots. Number 2, sketch the graph. And number 3, express your answer in a expression like this. Now let's start with the simultaneous equations involving quadratics. First, I'll give a little recap on linear equations. Linear equations are basically straight lines. They're represented by y equals mx plus c. On the graph, there are straight lines, and when you're doing simultaneous equations, normally there would be two linear equations. So that would mean there would be two straight lines, and you were supposed to be finding the intersection point. Now that you're going to be dealing with quadratics, there's also going to be a curved line. There are going to be intersections, and you're going to find those intersections. So now instead of two of these, you will be having one of this and one of this. Y equals ax square plus bx plus c. You'll be having one quadratic and one linear equation. Now there are a few possibilities about what can happen when you have these two equations. The first possibility is that you have the quadratic equation and a linear equation passes through it, and there are two intersection points. Another possibility is that the line touches the graph and there is one intersection point. The last possibility is that the line does not touch the curve at all. In this possibility, there are two intersection points. In this possibility, there is one intersection point, and this line, if you notice, it's the tangent of the curve at this point. Now that we know this, we can solve questions related to the quadratic equations. Let's begin with the first example. Alright, in this question, they have asked us to find the intersection points of these two graphs. One is linear, as you can see, this one is linear, and this one is a quadratic. all this you have to follow the exact same method you follow with the two linear equation graphs. You have to use substitution. For example, over here y is the subject, so we can put this in this. So if we put this in the formula, we can get x square plus minus 2x plus 1 whole square equals 2. What I did in this is put this in this y, because y is equal to 2x plus 1 minus 2x plus 1, and this is also y, so I added it here. Now we will solve this equation. X square plus minus 2x squared will be 4x square, 2ab will be minus 4x plus 1 minus 2. I brought this 2 here as well. Now we will solve this equation. It will be 5x square minus 4x minus 1 equals 0. So we can factorize this. Now that we have it factorized, it will be x is equal to minus 1 over 5 and x is equal to 1. Now we can put these values of x into this equation and get the corresponding values of y. Let's do this one first. Y equals minus 2 minus 1 over 5 plus 1. I substituted this value of x for this x. So now we'll get, if we use this, it will be 2 over 5 plus 1, 7 over 5. This is the first value. The next value will be, we'll use 1. It will be minus y is equal to minus 2 plus 1, because 1 will not make any difference when it's being multiplied. It will be minus 2 plus 1. Y is equal to minus 1. Now we have both of the points of intersection and we'll note them down here. The first point will be minus 1 over 5 comma 7 over 5, because that's the value of y. The second will be 1 comma minus 1, this and this. So that's all there is to simultaneous equation in quadratics. It's as simple as normal ones. All the only difference is that there are two values instead of one, and the two values you get them because of the square. When you take the factors, they turn out to be two values. Now that we know this, there's another type of question that comes in the exams. We'll practice one of those as well. Now in this question, they have given us a linear equation and a quadratic equation, and they have said that this value is unknown, this is k. What value of k will mean that this equation will be a tangent to this equation. Now what they're trying to say is, if this is the graph of the quadratic, for what value of k will the graph of this one look like this? They want us to find out the value of k for which the graph will look like this. Now in order to do that, first I'll have to teach you how to know if the graph will be a tangent, if there will be two intersection points or if there will be no intersection points. Basically, if you have a quadratic equation like x square plus x plus 5 and a linear equation y is equal to 3x plus 2, we can find out if there will be an intersection point or not by equating both of them. Right now both of them have y as a subject. We'll equate them. So it will be x square plus x plus 5 equals 3x plus 2. I substituted this value of y into this y. So now we can solve this. X square minus 2x plus 3 equals 0. Now if we use the determinant is the b square minus 4ac I taught you in the last video. This will be a, this will be b, and this will be c. b square minus 4ac. So it will be 4 minus 4 into 1 into 3. This will be negative. 4 into 3, 12. This will be negative 8. Because it's negative, it means that these lines will not intersect. If it was positive, it means the lines would have two intersection points. And if it was 0, it means that the line would be a tangent. Now, if it was 0, the line would be a tangent. Remember this question, they want this line to be a tangent. So we need the determinant to be 0. So as that is the same as that question, we'll equate these two graphs. So it will be x square minus 4x plus 4 equals 2x plus k. Now with that, now we'll solve this. X square minus 6x plus 4 minus k. Now in this, the tricky part is finding out what a, b and c are. It's not that tricky, it's really easy. Over here it's 1 because there's no coefficient. This will be a. Over here minus 6 will be b. And over here you can see there's 4 and minus k. Because k does not have an x, this will also be included in c. So 4 minus k is c. It's not only 4, it's minus k as well because there's no x. And as you remember, if there's no x, it means it's included in c. If it was kx, it would be included in b as well. Or if it was kx square, it would be included in a. But right now it does not have an x, so it's included in c. Now let's use the determinant, which was b square minus 4ac equals 0. The reason I put equals 0 is because we want the determinant to be 0 in order for this line to be a tangent. Like I taught you before, if the determinant is 0, the line will be a tangent, so we need it to be 0. We will use this now. It will be 36, 6 square is 36, minus 4a, a is 1, and c is 4 minus k. 4 minus k equals 0. So it will be 36 minus 16 plus 4k equals 0. Now that we do this, 4k equals minus 20, k equals minus 5, y equals 2x minus 5. This is the value of k, and this is the equation when it is going to be a tangent to this curve. That's all there is to the simultaneous equations, and the last thing we have to do in this chapter is modulus quadratics. If you do not understand this, you can just watch the video again. All there is to it is that when you equate two graphs, the determinant, it needs to be 0 in order for one graph to be a tangent. It needs to be more than 0 if you want there to be two intersection points, and it needs to be negative if you want them to not intersect at all. So sometimes they ask you to make the graph instead of giving you the question as it is. The last thing to do is draw graphs of quadratic modulus equations. I taught this to you in the first chapter as well. I'll teach it again. Basically, modulus is making something positive. For example, if it's positive 4, it will remain positive 4. If it was negative 4, it will become positive 4. If it was negative 6, it would become positive 6. So basically, it makes everything positive. So the same thing applies to graphs as well as quadratics. Let's say we have a quadratic equation like this, and it was let's say x square minus 6. So this would be 6. Y is equal to x square minus 6. And now they want us to draw the graph of x modulus x square minus 6. So what you would do is the parts that are negative, which are below the x-axis, you will take them and flip them above with the same distances. For example, if this is 6, Over here at positive 6, if this is minus 6, over here at positive 6, it will flip over and it will be like this. And this will be the graph. And you'll erase the parts that are below. And here you have a graph of a modulus quadratic equation. Let's try that again, but with a slightly different example. Let's say you have this equation and it will be minus x square. This is a basic graph, but it's flipped, it has a maximum point. Now this is okay as the graph of minus x square, but if this was modulus, you'd have to flip this whole graph because it is below the x-axis. So all you'll have to do is draw the graph exactly as it was but upside down. And that's the graph of the modulus equation. You'll have to remove this part. Let's try that one last time, but with a different question. This time let's say the graph is y equals minus x square plus 3. So if this is 3, the graph will look like this. Now the same as before, let's add a modulus. Now we'll have to make the negative parts positive. As you can see, these parts are negative, the ones that are below the x-axis, and we'll have to flip them. In order to flip them, we'll just reverse them. You just have to basically reflect them. It's not that big of a deal. Now that's done, you just remove the parts that are negative and you have the graph of the modulus equation. That's all that there is to the chapter of quadratics. I'll now be making a video of chapter 3 as well.